Learning target 7, evaluate a quadratic equation in the real world context and interpret the meaning. So for these ones, you have to be pretty good at doing quadratic formula and all of the different types to solve them. So quadratic, factoring, squaring. If you are not good at these, please come see me before school, after school, homeroom, lunch, whenever. Make an appointment. Rewatch the videos. We need to be really good at that. So here, these are like some real world things where we can use quadratics to solve these. So the product of two positive consecutive integers is 156. Find the integers. So product means I'm going to multiply them. So it would be like, and they're consecutive. So that would be like, it would have to be 2 and 3, and 2 times 3 is 6, or 5 and 6. 5 and 6 is 30. So, but these aren't what we're looking for, so that has, but I'm just saying that's, they're consecutive. So what I know is that if I pick this one, if I call the first number x, oh, that's not dark enough now. If I call that first number x, and I'm multiplying it by that second number, and that second number is 1 bigger than x, so it's x plus 1. This is going to equal that 156. A lot of you are probably thinking to now set it equal, like x equals 156 and x plus 1 equals 156. We cannot do this because you can only do that if this equals 0, and this does not equal 0, so this is a big, we're not going to do that. So what I have to do now is I have to distribute. X times x is x squared. X times x is 1x, or just x. And now I'm going to subtract over my 156. Now there are two ways that you can do this. You can do the quadratic, or you can do the box method and factor. I'm going to do the quadratic just because I don't feel like listing out factors of 156. I don't know those off the top of my head. I'm not going to use it. I'm going to use the quadratic now. So I'm going to say x equals, so I'll write that up here, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to have negative b. B is 1, so I have negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 156 all over 2 times 1. I'm going to have negative 1 plus or minus the square root of 1. Negative 4 times 1 is negative 4. Negative 4 times negative 156 is a positive 624. 2 times 1 is 2. 624 plus 1 is plus or minus the square root of 625 all over 2. I'm going to write this over here now. 625, what is that? 25, I think, yep. So I'm going to have x to equal negative 1 plus or minus 25 all over 2. So I'm going to have negative 1 plus 25 over 2, negative 1 minus 25 over 2. So then I'm going to get 24 divided by 2, which is 12, negative 26, which is negative 13. So there are my two roots. But in this problem, it's saying the two positive consecutive integers. So what all that is telling me that if I take 12 times 13, that's going to give me 156, and they're positive consecutive integers. So even though I get the negative roots, these are the correct roots, what I'm looking for is two positive consecutive. So my answers are 12 and 13, and I use the quadratic to find that. Now you could have easily have done this. X squared, negative 156, and then you would have gotten 13 and 12 and blah, blah, blah. But I didn't know right off the top of my head that 12 and 13 worked. So that's why I didn't use that. All right, so we have the length of a rectangular pool is 10 meters more than its width. So here, this is 10 meters more than this. If this is x plus 10. The area is 875 meters. Find the dimensions of the pool. So again, area I multiply. So I'm going to have x times x plus 10. That's going to equal 875. Again, I can't set it equal. I can't set them equal because this is not 0. So I have to distribute. X squared plus 10x equals 875. X squared plus 10x minus 875 equals 0. Again, you can use the box method. I don't know factors of 875 off the top of my head, so I'm not. I'm going to use the quadratic. So I'm going to have x equals negative b, so it's going to be a negative 10 plus or minus the square root of b squared minus 4 times a is 1 times c is negative 875 all over 2 times 1. So then I'm going to have negative 10 plus or minus the square root of 100. Negative 4 times 1 is negative 4. Negative 4 times negative 875 is going to be plus 3500 all over 2. So I'm going to write this up here now. Negative 10 plus or minus the square root of, what is that going to be, 3600 all over 2. So I'm going to have negative 10 plus or minus the square root of this is going to be 60 all over 2. So then I'm going to have negative 10 plus 60 divided by 2, which is going to be 50 divided by 2, which is 25. And then I'm going to have negative 10 minus 60 divided by 2. That's going to be a negative 70 divided by 2, which is going to be a negative 35. So those are my two roots. But up here, I'm looking for area. And I can't have, and these are lengths, so I can't have a negative length. So all it's telling me is that x then would be the smaller one, right? This would be the 25. And then this would be that 25 plus 10, which is going to be that 35. That same number down here, except it's positive because we can't have a negative length. So we just change our answers to make it go with the real world problem. Alrighty. Alright, so the equation h equals negative 4.9 t squared plus 7t plus 2.2 models the height of a stone thrown in the air. This 4.9 has to do with like gravity and stuff. You're going to see that number a lot when we're talking about throwing things. Where t is in seconds and h is in meters. So I'm going to have t is in seconds, h is in meters. So that would be like my x value. This is going to be like my y value. If you look, that would be like where my x's are. This is where my y would be. So we have 3 different questions. I'm going to answer each of them separately. The first thing I just want to notice is this graph. Whenever you throw an object, you will get a parabola. If you think about it, it starts at the ground, it comes up. This is the shape of something if you throw it in the air. It comes up, and then it comes back down to the ground. So anytime that we throw something in the air, we're going to get a parabola. We're going to work with that later. So the first question is, how long was the stone in the air? How long was the stone in the air? So for this, I'm looking at the time from here all the way to get to here. So I'm looking at it from here to here. This answer is where I'm starting, so I'm looking at, and that's kind of negative. I'm not starting there. So I'm only going to end up with one real answer on this, even though I'm going to get 2 roots. So when I'm looking for how long the stone was in the air, what I'm really doing is I'm trying to think of when is that height 0, right? The height is 0. So I'm going to get 2 answers, but I only want the positive one because that's after it ended. So when I make h equal to 0, I'm essentially finding the roots. So then I'm going to have this. 0 equals negative 4.9 t squared plus 17t plus 2.2. And if you don't like the 0 on that side, put the 0 on this side. I don't care. Now I'm just going to do the quadratic. So x equals negative b, negative 17, plus or minus the square root of 17 squared minus 4 times negative 4.9 times positive 2.2 all over 2 times negative 4.9. I'm going to get my calculator out because I don't know a lot of this off the top of my head, so I'm going to do negative 17 plus or minus square root of 289. Negative 4 times negative 4.9 is a positive 19.6. Positive times a positive is going to give me a positive. So I'm going to add this to 43.12 all over negative 9.8. So then 289 plus what, 43.12. Could have probably done that one in my head. Oh well. Negative 17 plus or minus the square root of 332.12 all over negative 9.8. So I'm going to draw a little arrow over here. So I'm going to have negative 17 plus or minus 18.22 all over negative 9.8. So I'm going to have negative 17 plus 18.22 over negative 9.8. And then I'm going to have negative 17 minus 18.22 all over negative 9.8. So 9.8. This one I'm going to get to be a negative 0.124. And this one, negative 17 plus 18.22 divided by 9.8. So remember, this one will give me a positive because this should be a negative on top, negative on the bottom. So this one I'm going to get a positive 3.5939. So I want the positive answer, right? That's this one. This number right here goes with this. But after, so I'm waiting for it to land, that's going to be this number right here. So I can say that the time for this one is going to be approximately, let's just say, 3.6 seconds. So right there at that point, so I found the roots. It started here, it ends here. I wanted this one where it ended, so it's that second one that I found, the bigger one. That second one where I found it. All right, the second question. When was it 10 feet tall? So if I look up here, 10 feet, right? There's going to be 2 points where it's 10 feet. There's going to be one here and one here. So now what I'm doing is I'm just making my h equal to 10. So I'm going to have negative 4.9 t squared plus 17t plus 2.2. Instead of equaling h is now 10, equals 10. To solve this, I'm going to subtract 10 over negative 4.9 t squared plus 17 t, what is that, 7.8? Yeah, so minus 7.8 equals 0. So now I can use my quadratic formula. Negative 17 plus or minus the square root of 17 squared minus 4 times negative 4.9 times negative 7.8 all over 2 times negative 4.9. So I'm going to have x equals negative 17 plus or minus, I already forget what 17 squared is. That's 289. A negative times a negative is going to be a positive. So 4 times 4.9 is 19.6. 19.6 positive times a negative 7.8 is going to be a negative 152.88. And then this was a negative 9.8. So 289 minus 152.88 is going to give me, so I'm going to have x equals negative 17 plus or minus the square root of 136.12 all over negative 9.8. And again, I'm going to come up here now. So then I'm going to have negative 17 plus or minus 11.67 all over negative 9.8. Let's put a point. So negative 17 plus 11.67 over negative 9.8, and negative 17 minus 11.67 all over negative 9.8. And when you do the math, let's see, 11.67 divided by 9.8. So I'm going to get 0.544 here, positive, right? 0.544, that would be right here. 0.544. And then over here, I'm going to get 17. I'm going to get positive 2.93. So that's going to be right here, and these are both in meters then. So what was the, when was it? Oh no, when. This is not, this is seconds. So after how many seconds? After this many seconds and after this many seconds, there's 2 spots where it's going to be that height. So 2.93 and 0.544. And then the last question, which is actually the easiest one. What is the height of the stone when it is thrown? So when I'm throwing it, the height, so if like we look, it's going to be like somewhere around here. It's looking like somewhere over here. The height of the stone when I'm throwing it. So the height of the stone when I'm throwing it, that's telling me that right now that when I'm throwing it, my t is equal to 0, right? And I know that this is because when I'm throwing this is asking me for my y-intercept. And my y-intercept is always when my x value is 0, and we already said that t is my x all the way back here, right? T is the same thing as x comma y, my t is 0. So I'm just plugging in 0 for t. That's all I'm trying to find is my y-intercept. So then I'm going to have this, negative 4.9 times 0 squared plus 17 times 0 plus 2.2 equals h. I'm now trying to find the height. I'm trying to find h. This is going to cancel, this is going to cancel. I'm going to add 2.2 equals h, so 2.2 meters. 2.2 meters. Oop, where is it? There we go. Before class, Susie wants to build a garden that has 3 separate rectangular sections. She wants to fence around the whole garden and in between each section as shown. The plot is twice as long, little typo, twice as long as it is wide, and the total area is 200 feet squared. How much fencing does Susie need? So try and do this using the quadratic, remembering that area is base times height, so there's a little hint for you.